All right, the last one. Remember to treat numbers as numbers. This is just negative 24 divided by negative 8, which is positive 3. We're not going to subtract them because they're not exponents, so we're not going to apply exponent rules to them. Now, we have 5 w's in the top and 2 in the bottom, so 5 minus 2 means there's 3 left over in the top. Then we have x to the 9th power. There are 7 z's in the bottom and 3 in the top, so 7 minus 3 means there are 4 z's left over in the bottom. To make sure it's fully simplified, 1, make sure your fraction is simplified. 2, no common bases. 3, no negative exponents. 4, just make sure all of your numbers are evaluated. That's how we know that our problems are fully simplified. All right, a really small number is going to have a negative exponent. A really big number is going to have a positive exponent. And that should be really helpful. So scientific notation, we want to make this between 1 and 10, so that'll be 6.0. You don't have to write the 0.0 if you don't want to. I just think it's more formal and it looks better. This is a really small number, so it's going to be times 10 to the negative power. 1, 2, 3, 4. So times 10 to the negative 4. .51 times 10 to the 1, 2, 13. Since it's a really big number, it's going to be a positive exponent. So really big numbers have positive exponents. Opposite way. Negative means we're going to move to the left. So I'm just going to write 3.42 here. We're going to move to the left 6 places. 1, 2, 3, 4, 5, 6. Okay, so that's 0.0000342. You don't have to have the 0 in the front, but again, I think it just looks better. Times 10 to the negative third, so we're going to go to the left 3. 1, 2, 3. So that's going to be 0.00. Nope. 10. 0.0718. And that's it. All right, rewrite each expression in rational exponent form. Remember, this is power over root. So this is negative 27. The power is 4. The root is 5. Now, if you have a negative base, it has to go in parentheses. Okay? I took off half a point from a lot of people on the quiz because they forgot to put parentheses. So, negative bases need parentheses. This is a positive base of 72. The power is 9. What's the root here, since there's no number? 2. It's a square root. Yep, so there's a 2. So yeah, 9 over 2. So if there's no number, there's an invisible 2 there. Now we're just rewriting in radical form. So again, power over root. So this is the 5th root of negative 80 raised to the 4th power. If you want, you could write it like this. It's up to you. I don't care which way you write it. So 3 is the power, 2 is the root. So this is the 2nd root, or the square root, of 252 to the 3rd power. Now, do I really need the 2 there? No. Okay, but I don't care if you have it there or not. It doesn't matter. Square root is the same thing as the 2nd root. So it's up to you whether you put the 2 there or not. The next section says evaluate. Evaluate means plug it in your calculator. I do not need you to rewrite it in the other form. You just need to type it in. So we're going to hit, and let me share my screen with you guys. All right, so we want math 5 will let us type in any root that we want, and we want the 5th root of negative 32. And we get negative 2. What?
I'm not going to use it.
Math 5, and then type in 5, and then negative 32 under the radical. Did you get negative 2?
I did.
Awesome. Awesome, awesome, awesome. Okay, so now we want the 4th root. So math 5 again. The 4th root of 6561 raised to the 3rd power. And we get 729. And it doesn't matter whether you guys put the 3 under the radical or on the outside. (64) raised to the 5/2 power. So 64 raised to the 5 divided by 2. And we get 32,768. And then 1,024 in parentheses raised to the 3/5 power. And we get 64. If you ask me during a test how to type this in your calculator, I'm not going to tell you, because that's the only skill that you need for this section. The first skill you need is to know that you need to plug in a calculator. The second skill is plugging it in. Okay, so if you ask me how do I do this, I'm going to say, well, I can't just tell you how to do the skill, right? That's something that you need to know. So make sure you guys type it in on your own and that you know how to type it in. Linear versus exponential. Exponential is when you multiply by the same thing every time. Okay? It has a common ratio. So there's 2 things. That's our B value. Or you guys know for a geometric sequence, it's called the R value. They're the same thing. The A value is the y-intercept, which is 27. Okay, so y equals 27 times 3 raised to the x power. So again, we have the y-intercept and then the b value, what you're multiplying by. When you're adding or subtracting by the same thing every time, that's going to be a linear function because it has a constant rate of change. So the slope is change in y over change in x. Most times the change in x will be by 1. Okay, I'm not going to try to trick you like that on the test. Some in your homework assignment had +3. There's 1 question, but other than that, most of the time it's +1. So that makes our slope -3 divided by 1, which is just -3. And then our y-intercept is -5. Okay, when x is 0, our b value is -5. So y equals, and here's the equation, mx plus b. So m is -3, and b is -5. All right, again, you see the word evaluate. So evaluate the function for the given x value. So when x is -4, that means we're going to replace the x with a -4. And then we could use our exponent rules to do this by hand, but it actually will be easier to just type in our calculator because then we know it's correct. So -2 times 1/3 raised to the -4th power. And we get -162. All right, graph the following function. You can pick x values like -2 to +2 and plug it in by hand. Use your exponent rules and PEMDAS, or we can just type it in our calculator by hitting the y equals button. Type in -3 times 1/2 to the x power. And then you're going to hit second graph to go to the table. So there we have some good values. Normally, we just need to go -2 to 2. Sometimes we might need to go further, but most times there's enough good points from -2 to 2 that we can plot. So left 2, down 12. That one's off our graph, so you don't have to plot it. Left 1, down 6. 0, down 3. 1, down 1.5. 2, down 0.75. And then if you want, you can just graph the 0.3, the 0.1, and you can just see that it's getting really close to the x-axis. Okay? It never actually touches, but it does get very close. Make sure you guys don't just stop your graph here. I had some people on the quiz do that. I was like, wait, just because we stopped plotting these points doesn't mean the function stops. Right? The function keeps going on forever, which is why our domain is all real numbers. Okay, so domain is all reals because it extends on forever in both directions. More times than not, your range is either greater than or less than 0. In this case, it's below 0. It's never equal to 0 though, because it never actually touches 0. It just gets very close. If you're adding or subtracting a number on the outside here, then you're translating your graph up or down. So what it would look like, if you're adding or subtracting a number there, you would just be moving this up or moving it down. And that's when your range would change. Okay? But we're not adding or subtracting a number there, so therefore our range is just below 0. Okay? All right, determine whether the function represents exponential growth or decay. Identify the percent rate of change. We definitely struggled with this on the quiz. You guys got your quizzes back, so you can see if you got this question right or wrong. On the quiz, it was 0.65. Is that bigger or smaller than 1? Smaller. So if you're multiplying your numbers by 0.65, are your numbers going to go up or go down? Down, right? They're going to decay. You're multiplying by something smaller than 1, right? So they're going to go down. So that's exponential decay. So if your number inside the parentheses is bigger than 1, then it's exponential growth. If your number inside the parentheses is, and I actually believe that yours here says 0.2, right? And 0.2 is smaller than 1, which actually means that this is exponential decay. It's going to go down because it's 0.2. And here, 0.3 is less than 1, which is exponential decay. You are multiplying your y values by something smaller than 1, right? So you're taking a third of that number, which is going to go down. It's going to decay. Now, when we talk about the percent rate of change, it is not the parentheses, okay? For that deer question, a lot of you said it was 140%. It cannot be bigger than 100, and it can't be smaller than 0. Okay, it has to be between 0 and 100%. So it's not what's in your parentheses. It's what you're adding or subtracting from 1 to get to that number. So what did I add to 1 in number 20 to get to 1.02? 0.02. Yeah, 0.02. So as a percent, we move the decimal to the right twice because we multiply by 100, and that's an R value of 2%. Okay, so it's not growing very fast, but it's still growing by 2%. And here, what did I subtract from 1 to get to 0.2? Point what? What? 0.8. No, yeah, so this is not your R value. It's what you're subtracting from 1 to get to 0.2. So if you want to find the difference, you just do 1 minus that number. Okay, so you just do 1 minus 0.2, and that's your R value, which is 0.8. Okay? As a percent, we multiply that by 100, and that's 80%. Okay, what did I subtract from 1 to get to 0.3? 0.7. Yep. So R is 0.7, which is 70%. Okay, so your R value is not the parentheses. On the quiz, it's not 65%. It's 35%, because that's what you were subtracting from 1 to get to 65. All right, I will give you the equation on the test, just like I gave you the equation here. You purchased a used boat for $8,500, so that's our initial amount A. It decreases, which is why we're subtracting R, because it's going to decay, it's going to go down. 14%, we're going to move the decimal to the left 2 places, and that's going to be 0.14 raised to the T power. I like to put a 0 there so that you can see it's a decimal, otherwise you might miss the decimal. 0.14, thank you. And now we want to use the function to find what the value of the boat is in 5 years. Well, if it's decaying, then it's going down. So it's going to be less than 8,500. So let's plug that in our calculators. To get out of, you guys can hit second mode to quit out of the graphing function. So 8,500 times 1 minus 0.14 raised to the x power. Oh no, sorry, we're plugging in 5. So raised to the 5th power equals 3,998.63. So did it decay? Did it go down? Yeah, lost a lot of value. Right? 14% doesn't seem like that much, but over 5 years, it definitely, the price was cut in half. So, all right. The next one's growth. You can see there's a plus sign here. So you deposit $950, so that's our initial amount A, into an account that earns, so it's increasing, 1 plus 2.5%. So move the decimal to the left twice, and that's 0.025. So we want to know what the balance will be in 4 years. So let's plug in 4 for T. So 1,048.62. That means you went from $950 to $1,048. So you earned $98 over 4 years, which, I mean, it's good. You made money at interest doing nothing. All right, any questions before we move on to 6.5? All right. You can look at your quiz to see if you got these questions right or not. The first question did go pretty well. When the base is the same, like 14 and 14, then we can just take our exponents and set them equal and solve that equation. Okay, so I think that part went pretty well. Let's subtract 6x from both sides, and we get negative 5x equals 5. 5 divided by negative 5 means that x equals 1. Okay, if you don't have the same base, you need to make the same base, and I think this is a challenging part. So how do you do that? You look at the bigger base first, and you ask yourself, can I rewrite 100 as 10 to some exponent? Yeah. What can I replace 100 with? 10 squared.
Yeah, I was gonna say that, but I remember right.
10 squared, you are right. And if you were wrong, that's okay too. So I'm going to write everything else in there. I only replaced the 100 with the 10 squared. Now the key here is that when you multiply these exponents, you have to distribute the 2. Okay, I don't care if you rewrite this step or not, but you have to do 2 times 2x and 2 times 5. So we get, I'm going to move up here, 4x plus 10. So I'm going to move my x terms to the right. 4x minus 2x is 2x. I'm going to move my constants to the left. So 2 minus 10 is negative 8. And negative 8 divided by 2 is negative 4. All right, we do not want fractions. So how do I make this so it's not a fraction? Yeah. Negative exponent. So this is 3 to the negative first power. Is that correct, what I just wrote up there? No. Why not? There wasn't an x there in the first place. I cannot tell you how many students I had that just added an x. And I was like, but there's no x there, right? There's no x there. You can't just add one in. Okay, if there's not a variable exponent, there's just not one on that side, and that's okay. Okay, so 3 to the negative first. That was the last question on your quiz, the bottom right-hand corner. 27 can be rewritten as 3 cubed. Okay, that's a common one that you guys have seen a lot. No? So when we multiply this, we have to make sure that we distribute the 3 to the x and the 1. Okay, so we get 3x plus 3. So again, distributing is a very important part of these questions. So I'm going to move my constants to the left side. And we get negative 4 equals 3x. Divide both sides by 3. Is it okay to have a fractional answer? Yeah, absolutely. Okay, does it make you question yourself sometimes? Yeah. Yep, it can, but it is correct, and you can always plug it in to make sure it's correct. Right, let's just check. 27 raised to the negative 4/3 power plus 1, 1/3. And it equals 1/3, so we're good. So we know we did it right. Okay? The hardest question is probably when you have to change both bases. So 32, so can I rewrite 64 as 32 to some power? 32 squared is not 64. 32 times 32 is a really big number, right? So 32 squared, nope, can't do it, which means I have to go smaller for both of them. Okay, so we go smaller for both of them. 32 can be rewritten as 2 to the 5th power. So that means if I take 32 and multiply it by 2, that's going to give me 64, which means 64 is 2 to the 6th power. So power to a power, we're going to multiply. And when you multiply, you have to make sure that you distribute. So that's 6x minus 24. So we get x equals negative 6. All right, arithmetic means you're adding or subtracting the same thing every time. Geometric means you're multiplying or dividing by the same thing every time. Neither means you're doing neither. So here, I already know that it's geometric because the signs are alternating. Your signs can't alternate like that for an arithmetic sequence. Some can be positive, some can be negative, but they can't alternate like that. So we're multiplying by negative 2. And you need to check all of them. Times negative 2 times negative 2. So my R value is negative 2, which makes it geometric because it has a common ratio. Okay, when it says explain, your explanation is that R equals negative 2. That is how you're explaining that it's geometric. Here, 2 to 6, you're adding 4. 6 to 10, you're adding 4. 10 to 15, you're adding 5. So that's why you have to check all of them. Okay, you can't just check the first two. So that's actually neither. And it's not multiplication, right? Times 3 times not 3. So this one's neither. No common difference or common ratio. All right, write the next 3 terms. We know it's geometric, so we don't have to check every term now. We just need to find our R value, which is negative 3. So negative 18 times negative 3 is positive 54. Times 3 is 162. Times 3 is 486. You're right, this one's a negative. Negative 162. Yep. Right? Yeah. All right, this one we're how do I go from 32 to 16?
Times a half.
Yeah, times a half. Yep, we're dividing by 2. So half of 8 is 4, half of 4 is 2, and half of 2 is 1. For a geometric sequence, I will give you the formula. There's 2 things that you need to plug in. The first is A sub 1. A sub 1 is the first position in your sequence. The second thing is your R value. Your R value is what you're multiplying by. So here, how do I go from 4,000 to 2,000? Yeah.
Times half.
Divide by half, 2, which is multiplied by 1/2. Good. And then here, times 3. And then don't forget, this is raised to the n minus 1 power. Now, because this says a sub n, you need to make sure that you have an n there. Okay? I know you have to find a sub 10 in the next step, but do not write a 10 there. I want the general formula for any n value. Now we can plug 10 into our calculators. Okay, so 8,000 times 1/2, which 0.5 is easier to type in than 1/2, raised to the 10 minus 1 power, or you guys can just type in 9, right? Because 10 minus 1 is 9. I personally like to hit math, enter, and turn it into a fraction. I just think it's more accurate. You guys could also write 15.625. I'd be fine. I would accept either. All right, 9 times 3 raised to the 9th power. So we get 177,147. And then make sure you guys put your commas so I can read the number. And that's it.